0.2 that sounds like a bit better now. Yeah, that's right. Yeah. And no more than 50 elements. Two constraints. However, whenever we're doing linear programming, whenever we're constructing constraints.
Yeah, that's right. So Brianna's got a Mac, and I must put up into the Moodle site. We've found out, another teacher has found out how to get an emulator that works on a Mac. So that might help a couple of students as well. Okay. Oh, can't welcome Bianca. She's dropped out before she's started. All right, let's get this going. Oh, it is going. I'm going to cut off the start of this recording. What we're doing in Maths Methods, we're looking at functions and graphs. So in the first 2 weeks, we looked at writing linear equations and finding out how to write, or hopefully it was a reminder of how to construct an equation from 2 points or from a point and a gradient. We also, in the first couple of weeks, looked at the distance between 2 points. I think we revised a bit of Pythagoras' theorem and revised a tiny bit of trig. So that was the first 2 weeks, and now, even this is called lesson 4, but it's really been, this is the second week where we're really focusing on functions. So what I'd like you to do to start this lesson is just read this question number 4, and I just want you, there's a problem with it. I just want you to comment on the way this proposed situation is set up and identify what the problem is. Yes, Taylor?
Do we write it in text chat?
I like people that can talk, Taylor, so if you're willing to just express your thoughts, that would be great.
Yeah. They have 2 years there twice.
Yeah, so thank you, Taylor. So does someone want to add to what Taylor has just said? Why having 2 years twice? Why is that a problem?
Yeah, so as I was saying, different companies do suit different people. So
We would include that category in 2 separate calculations.
Yeah, and when you look at those separate calculations, is there a difference in the calculation?
So, for example, just because I use Vodafone as my mobile phone company, does not necessarily
If you had a 2-year-old child, which amount would you want to pay?
Zero.
Yes, Abdurrahman, do you agree with that? Yes. All right. So it's contradictory. You can't have 2 different costs for the same age. And again, the 16-year-old would make out that they were, they would say, I'm a child, not an adult in this situation. So when we are describing relationships, and when we, like, pay scales are often a relationship between the number of people and the cost. So we have to have a way of displaying what number is included and what number is excluded. So that's why I brought that one up. And so while we're talking about that, I may as well go straight to this slide to say that when we draw a graph, we do a solid dot to say that that value is included. Now, unfortunately, this doesn't have a scale, but the endpoints of this graph, the values are included because it's a solid circle. Over here in the green box, the letter A is part of the domain, so a domain is the x values. Part A is included and part B is included. Does anyone want to talk about this one down here? I'll start with A. Is A part of the domain in the second one?
Yes?
All right, so Brianna, it's good that you're responding. if you put up your hand in case there's lots of people who want to respond, which we haven't had yet, but yes is correct. Oh, wait a minute. I want to emphasise, I've looked closely. In this second one, this value A, yes, Bianca, why have you changed your mind? Why do you think no?
The constraints in this problem.
Because it says.
All right, so what? So the number is outside of the range. What can you see about the symbol that indicates that it's not included?
But now I want to take us to the
I don't know.
Can someone help Bianca out? Can you notice what they've done?
So we're going to do our introduction.
If I draw it larger, this one's got an open circle, and this one here has a solid circle. Right, give me a tick. Can you see the solid circle means it is included, the open circle means it's not included. So now the next thing to notice in the red, there's nothing red. Brianna, I don't... Are you colourblind?
I meant in the red dotted line section.
Ah!
Section dot point.
I can see that now. Okay, that's true. So if we look up here with the red dots, yeah, that's good. It is included. That's a little tiny solid dot. So in this section here with the graph, in the graph, the end point, if I called the end point A, that end point is included because it's solid. Everyone agree? All right. Now, when we look at the symbols, so let's go back to the symbols. We're saying that the domain, so the domain is the x values. That the domain is the value that includes the A. So A is less than or equal to x, so x is in the middle. Less than or equal, it includes the A. And x is less than or equal b. So here's b on the upper value, and b is included. Can you get out your highlighters? Can you highlight where it shows that the x value is larger than b and it does not include b? How have they expressed that in symbols? So for number 2, how have they shown that x is the values greater than b, but it does not include b? So if you're not familiar with this, I say see-through colours for highlight. The light blue is pretty see-through. Get the highlighter pen. If you're not used to it, just practice. And that's it. X is greater than b. So on the number line, x is all the values that are higher than the value b. All right, let's do the same thing. Where does it show for number 2 that the domain also includes all the values of x that are lower than a? It doesn't include a, but all the ones lower than a. Yep, so I'll just get out the laser pointer. So here is a symbol that x is all the values less than or a, and it's strictly less than. It does not include a. And over here, if we get out the highlighter again, oops, the domain is what we call a disjointed domain because it includes all the values less than a. And it includes them on to infinity, negative infinity. So now have a look at this symbolism. This reads x, and x is the domain values, or the domain values are the x values. X is an element from minus infinity to a, and union means combined with, if you like, and also all the values of x from b up to infinity. So there's a lot of notations, And you need to understand these notations. Textbooks written in different countries tend to have different notations. So we're a global community. We need to understand different ways of expressing the same information. In this one above, where x is between a and b, that's pretty easy to understand that the domain, as in this graph, if we call it a and b. All right, so it can be written as a is less than or equal to x, which is less than or equal to b, or x is an element, so that e is element, the square brackets, the element of the set from A to B. Wacky-do. So, as you do your weekly work, make sure you practice writing in symbol form. Oh, I'm glad you like this. All right, so let's go back to the start because I jumped around a little bit. What I want to do is to begin to describe, let's see, that when we are relating one object, and in maths it's usually a number, one number with another number, there's often a process. So you might have a relationship that the answer is going to depend on the original value. So it depends on the x, and maybe we're going to double the x. So if x was 1, so we'd substitute 1 in for x, then y would be double it, y would be 2. And x is a variable we can put in stacks of value. There are some relationships where there's no pattern. It's still a relationship. So if we just look at exercise 3a, they're saying that there's a 1-to-1 relationship, -5 maps onto -3, -1 maps onto 8, etc. That mapping is called a function if there's only one answer. So in B, x when it's 4 can have the answer of -1 or the answer of 3. They are different answers. That's okay. That is a function. But in this relationship in part C, two different numbers have the same answer. -3 has the answer 1, 5 is mapped onto 1. That is not a function. It's a bit of an odd definition, but visually, I really am teaching this in a different order to the slides, I'm sorry. Visually, if you can draw a vertical line which represents the y value, and the y value cuts the function once, it's a function. So if we look at part C, and this time I use a line, all right, that value, that's a value of x, it's only got one answer. It's a function. But here's a single value of x. Let's keep using the letter A. When x equals A, it has two y values. That is not a function. Give me a tick if you've got the idea visually of that concept. That's great. And Andy, welcome. We're having Brianna drop out and no, not Brianna. Day. Oh, I've forgotten her name. That's terrible. Starts with a Bianca. Thank you, Abdurrahman. So Bianca hopefully will get back in. All right, so with that understanding of whether it's a function or not by looking at the graph, I want you to decide if it's a function when you draw these things on your graphics calculator. So let's try part A. Now, can you write the function down? Let's write them down now. 2 part A, y equals x squared, take 9. X plus y equals 9. And x squared plus y squared equals 9. Now, before we go to the graphics calculator, when you write an equation on your graphics calculator, it's in the form y equals. First step, for part B, you need to rearrange it so that y equals. Can you write in text chat the equation B with y as the subject? So all you're doing, I'm hoping you can do it in your head, all you're doing is you're taking x from both sides, because across the equality, if you take x from both sides, actually sometimes people write it like this. Across the equality, you take x from both sides, so it hasn't changed the equality. X take x is 0, you get left with y. 9 take x is 9 take x. I was hoping people would write that in text chat pretty slick, because I was also hoping, thank you Taylor, I was also hoping somebody might write y equals minus x plus 9. Smiley face if you agree that this form of the equation means exactly the same as this form of the equation. So that flexibility of reading equations and knowing that if you put the terms in a different order, the x term includes the negative, it can go first. The 9 constant includes the positive and we don't write it. So when you swap the order, you must show that it's actually positive 9. Okay, so we've got the equation. It's a bit of a habit to write the x term first. It's not better, it's just different. So I'm, in my calculator, going to write y equals negative x plus 9. Now part C, I might leave out part C. All right, we won't do part C. So grab your calculators. If you have them.
Now I'm going to do some more examples of these videos,
And we're going to turn it on and go to the menu. We want to draw a graph, so the grey navigator pad to the graph.
any recordings that I make can be found in that folder for this topic.
That's it.
So here's our table of information.
I've got the recording thing in the way and it won't let me shift it.
Step 2 is to construct. Now let's start off with the two.
I'm annoyed. That's odd. Ah, now I've got it. Okay, so the first equation in the graph menu, press the blue execute button. We want x squared take 9, so the variable x is under the pink alpha key. X squared, subtract 9. Blue execute, function 6 does the drawing. Now it's a bit off my view window. We've just started talking about domains. I just want to show you, if you do shift trace and then the arrow key, the little dot will appear in a minute, I hope, onto the screen. Here it comes. We can see that when x equals 3, y equals 0. So the domain that we need is about -5 to +5. But the range, if I go down with my trace, it's off the screen at -4. So I'm going to try -10. So shift view window, I'm going to set the x minimum. Actually, the x minimum of -6.3, that's fine. Let's leave it there. Maximum 6.3, scale of 1, all fine. I'm just navigating past them. But the y minimum, we want to be negative 10 because it wasn't showing on our screen. And the maximum, let's make it positive 10. All right, so execute. Now let's redraw it, and it's showing. So give me a tick if you kept up with me changing the view window across, because I did it reasonably quickly, across if you got left behind and you don't really know what I did. Okay, so, all right, some ticks, some crosses. I've taken a little while to see that. Could you reply again, because I wasn't watching properly? Across if you didn't catch up, if you don't really follow what I did. Abdurrahman, were you the only one? Yes, Taylor?
My graphics calculator is telling me it's an invalid setting.
Okay, so did it draw the graph? Yes, Taylor?
Yes, it did, but now, like, when I changed it, now it's not. So I think I did something wrong.
Taylor, are you happy to share your desktop so that we can see?
It's an actual graphics calculator, so it's not on the screen.
Okay. Taylor, my mind at the moment is a blank as to what you might have done. Is it a fairly old calculator? Do you have to use the negative in the bracket?
Well, I've used negatives before and I never had to.
No.
It's not that old.
Good, yes, because the more recent ones you don't have to worry, and so that's much better. Taylor, let's just, it might come to you what you've done wrong. You didn't put the negative value on the maximum and the positive value on the minimum so that it was not a proper domain.
I don't think so.
All right, let's stop there because sometimes we do some odd things at times. All right, now if you look at this view window of the parabolic function, so I'm adding descriptors. The function was in the term y equals x squared minus 9. The highest power on the x was a squared and the highest power on the y was a 1. It's going to be a quadratic, and the shape of a quadratic is a parabola. And if we did vertical lines, you would see that it only cuts once. So this is a function. Right, let's try the other one. Let's press exit. Let's delete whatever you had. So highlight Y1. Function 2 on mine chooses delete. Yes, I really want to get rid of it. Now I want to put in the equation y equals negative x. So negative variable x, that's the other spot that sometimes... but if your graph drew, it's not putting in the variable x. Plus 9. Blue execute, and we'll draw it. So that's a straight line. Can you in text chat, is the straight line a function? Is there only one y value for every x value? So is this line a function? So we need to make sure that we put the numbers in the right order as well, even though the orange is actually... So it's a function if you did a vertical line, it only cuts the drawing once. So if you want to change your mind, you're welcome. And some people are doing it privately. Andy, I would love you to respond to all participants so that we can see each other's answers. All right, so the equation was an equation of a line. You might have heard people say linear function. A line is always a function, so linear function. Now let's just play around with the view window once more. So it's going off the end of my screen. I want my X domain larger. I can trace it to get an idea. If I go Shift Trace and I navigate to the right, that little cross goes over. I'm taking forever. So the Y value is 5. It disappears when Y... Oh, it's the X value I'm worried about. It disappears when the X value is over 7. So let's make the domain minus 10 up to positive 10, and the Y values are not too bad. So let's only change the domain. So you go yellow shift to choose the view window. We're going to make the minimum negative 10, blue execute, the maximum positive 10, blue execute. The rest, mine is still showing minus 10 for the Y and positive 10 for the Y maximum. So now I press exit. I can draw it again on this new view window, which shows the X intercepts. All right. So the first two were functions. Part C is a circle. If I quickly sketch a circle, it's a circle with a centre. I don't know. No, I'm not sure where the centre is. So I'm just going to draw a circle. Hold my shift key down and that will make a perfect circle. Now, if you try and draw a vertical line through this circle, is the circle a function? So with the circle, if I call this value A, when X equals A, it has two values on the Y-axis. So for one value of X, it has two values of Y. Is it a function? People are agreeing no. You're correct. The circle is not a function. It's a relation. There's a relationship between the X and the Y, but it's not a function. A function is a special relation.
Yeah, exactly. So once again, blue is 8, and we haven't seen green yet, but we can now see that is equal.
So I've jumped around. We've already talked about the domain of a function being the X values, and the range is the Y values. I've talked a little bit about functions and relations, so now we need to talk about the notation of a function. A function is a special relationship between two things. So one of them is represented by X, and to get a value of X, we say that we're going to do some sort of operation to it or put it through a machine, and the value of X will come out after we've done things to it. So you are used to saying the answer is Y. The answer Y will be when we do something to X. Here they're using the example when we make X 3 times as large, triple X, take away X squared, and add 2. That is our function. Now, that function is a quadratic, and it's actually a negative quadratic, so it's going to be pointing downwards. And we already worked out that a quadratic was a function. I'm really glad that you've got back, Bianca. Welcome back. So this is a function. This process of tripling the X, taking away X squared, adding 2. So instead of saying the answer is Y, we're going to emphasise that it is a function of what we do to the x variable, and the way we work it out is 3x minus x squared plus 2. So that's where the function notation comes in. You probably used to having the y, but the y can be replaced with function of x. Now the function doesn't have to be represented by an f. We could have said we are going to do something to the x variable. Let's call it g of x. So g of x is still the function. And what should we do to x? Well, I'm making something up. Let's say that we're going to double x squared and take away x. So that's how we get the function notation. Can you text chat? Can you text can you text chat the function value when x equals 0? So can you put that notation, f of 0 equals, and put 0 into the function? So wherever x value appears, you put a 0. It's called substitution.
So we can basically use ratios using fractions to help us figure out the exact amount that we have.
You've been tricked, you guys. Just look at it very carefully. When you put zeros in for all the x's, do you agree with Taylor? So have a careful look at that function. 3 zeros is 0, 0 squared is 0. All right. So if you want to change your answer, you can, but otherwise just do function of 3. So now let's try f of 3. So replacing x with 3.
Milk is 2 parts. Together, they are 3 parts. So there's 3 in total if you add those 2 together. And how many of those are water? Well, it's 1 out of those parts. So essentially, it's a fraction 1 out of 3. So water is 1 out of 3 of those parts. And we know we have 500 mils.
So what you're doing and you're thinking, I hope.
Is water, 1 part is 500 mils.
All right, I'll do it a bit slower, Bianca. Bianca, we've just defined what a function is, and we're changing the notation. So instead of saying y equals something, we're saying that this is a function, and it's in terms of the variable x. So we're just practicing that if x equals 3, we write function when x equals 3 equals. So instead of x, we're putting 3. So that's 3 times 3. Subtract. Instead of x, we've got 3 squared plus 2. So I'm hoping that people will write in text chat. That's, it is 2. 3 times 3 is 9. Take 3 squared is 9. Add 2. The value is 2.
So the first thing we're asked is fairly straightforward. What does this ratio mean? We've already learned what.
So I'm also trying to emphasise that these answers have meaning if you write them in a symbol sentence. So saying f of 3 equals 2 is different to just saying 2. We've just seen that f of 0 equals 2, and that's actually a different value of x. So we've got to be careful that we express, like a number in isolation doesn't have meaning. All right, please, let's try f of 3. If I do f of negative 3, so I'm replacing x with negative 3. It's 3 times negative 3. Subtract negative 3 squared. So just be careful, the negatives get squared as well as the 3, plus 2. 3 times negative 3 is negative 9. Subtract negative 3 squared. Negative times negative is positive. 3 times 3 is 9. So it's take 9 plus 2. So on the last line, you write function of negative 3 is minus 18. Minus 9, take 9 is minus 18, plus 2 is 16. Excellent, Taylor. We all should watch what you say. So, can I have a smiley face if you are confident with negative numbers?
So that's going to mean that the fraction
That's very good because many students don't get a lot of practice. So if you know what you're doing but you're getting wrong answers and you think it's because you've got a bit of trouble with negative numbers, you can Google negative numbers and do a practice or something like that. Or you can say, Jan, can you just give me a bit of practice of working with negative numbers? I'll probably get something out of a textbook and send it to you. Now, this chapter has so much notation. It shows you more than one way of writing the same thing. So, you can also say the function g with respect to, or such that. So I'll just do that. Those two little dots, sometimes it's read as such that. Okay, so the function g such that x becomes. So that arrow, I'm reading it as becomes. In other contexts, it can be read as approaches. So isn't that a bit confusing? Our symbols, just like the English language, have more than one interpretation. Good, Brianna. So the arrow is approach. So the function g with respect to x approaches x minus 4 on x. So find the value. So your turn again. We're using the function notation that it's a g function. We're going to put 1 wherever x occurred. The relation written up here was x, so we're putting 1 instead of x, minus 4 over x, 4 over 1.
Yep, you're exactly right, Paige. So what Paige has said is that the answer is 100 grams.
So g of 1 is going to be 1 minus 4.
So let's see what
I hope that you agree with that.
So we've seen that 150 grams equals 3 parts. We know that the fraction was 3 out of 5. Avocado was 150 grams, so it's 3 parts is 150. So what Paige worked out...
Oh, my apologies, people. My text box wasn't open far enough. So well done. Let's go on to g of 4. I'll give you a moment to get ahead and see if you can get your answer before I've shown the process. We're replacing x with 4.
So that's the basic way we go through and work that out.
Anything divided by itself is 1. And on the last line, you've got to write your subject. The function g when the variable x is 4 is 3. Excellent, Taylor and Abdurrahman. Yep, Brianna, well done. So, Andy, are you doing okay with these?
Is that there are 5 parts in the recipe. So if we go with the same logic as before,
All right.
that's going to mean 600.
And again, if people are up to date with their weekly work, you would have seen some of this already. Give me a tick if either from, last year or from doing the weekly work, you've seen some of this already. So I think that's good, Abdurrahman. So I want to really push, excellent, Brianna. I want to really push that. This lesson will be easier on you, easier on your learning, if you've seen it already, and I'm sort of confirming and extending what you've seen already. Now, it is relatively early in the week. Now, I want to use this graph for a different reason. I very briefly mentioned domain at the start of the lesson. The domain are the x values. Now, if I put a restricted domain on this function, so I'm going to put a solid dot here and a solid dot here. I'm going to say, what is the domain from x value of 0, and I'm making up my own scale, x value of 15. Can you try and write down the domain using less than or equal symbols. So notice I've got a solid dot, so it includes those numbers on the ends.
Not just this week, but next week as well.
So
Crashing
I
out
recommend you start with the lowest value. 0, is it in the domain? Yes, it is, so it's less than or equal. The domain is the x values. And x is less than the maximum value. So the maximum value is 15. And is 15 included? Yes, it is. It's a solid dot.
go to our graphic calculator. We are going to be putting these
Now, if you're trying to text chat this, you probably have to do the less than or equal to get the less than or equal concept over. So,
coordinates of the places where these two lines cross.
if you're in the middle of writing, finish. If you haven't started yet, I'm going to change the problem. I want you to write down the domain, and I'm going to do an open circle. And the open circle, you remember, means it's not included. So I've done an open circle for the start, which I'm going to say is 4. And I'm going to do a solid circle for the end, which I'm going to choose as 18. And I'm going to do it here. So when x equals 18. Can you try and write in symbols the domain? So I'm hoping you're typing, and the way I recommend you do it is because x is between two values, right? So the domain of the range of x values, I start with the lowest one, which is 4. And is 4 included? No, it's not. So it's strictly less than the x values, which is the domain. Then I go to the top value, which is 18. Is 18 included? Yes, it is. So x is less than or equal to the top value. Can you people give me a tick? Do you follow how I've constructed that domain? All right. It's very hard that you've dropped in and out, Bianca. Bianca, can you tell me which bit or more than one bit is causing you difficulty?
At the moment, it's most of it because I left and then came back. I'm just lost.
Okay. Well,
I'll figure it out later in the week if you want.
yeah, that probably is best, Bianca. Thank you. But I would like to say, if you can sort of just quietly think, I have really, if you're familiar with the less than symbol, that's what I thought might be the problem. That symbol is less than. All right, and this is greater than. That can be something that people have to learn. All right, I'm going to do another one. Just looking at the time. One more and then we... let me just check. Yeah, we've covered that. I've jumped around a lot this lesson, which is not fair. All right, I want to do this last slide. So I asked people to have their calculators ready. What I'd like you to do is on your calculator simply do like the function x equals x squared. I'll just rewrite that first line. The function in terms of x is x squared. Now what you're going to do on your calculator is y equals x squared. So they're equivalent. So let me also get my graphics calculator there.
So, for homework this week, you need to complete the second page of section 5, which is the one on the mobile phone plan, as well as section 6 of the workbook.
So I'm just going to hit the menu button.
Now, as I said at the start,
I've got graph highlighted already. Press the blue execute. Now, I left my calculator on, so I've got to exit back to get to the menu. I've also got stuff there that I want to get rid of. F2 deletes it. So my equation was y equals x squared. So the variable x is under the pink alpha key, x theta t, and I'm squaring it. That's it. Press execute, draw. Now when I look at that function really carefully, there is no value of y negative, there's no negative y value. So the range, the y value is greater than equal to 0. So the y values are all positive. Can I have a tick? Can you see that the y values are all above 0? So the y values are up there. Right, the next thing I'd like you to notice is that x is defined for every value. I could go to negative infinity and this parabola would go on forever, and I could go to negative infinity through all of those negative numbers to 0, to all these positive numbers to positive infinity. X can take on any value in the real number system. So the real number system includes root 2 and pi and fractions, all right, the real number system. So now let's go back. When we look at this summary table, it's just talking about the domain. It says that x is an element of the real number system. So you've got to understand that the real number system is from negative infinity to positive infinity. The square root of x is positive. You cannot find the square root of negative 5 in the real number system. Okay, we're not going imaginary numbers just yet. So you cannot find the square root of a negative number. So x cannot take on a negative number. 0 is a bit odd. By definition, we say the square root of 0 equals 0. All right, so that's a bit odd. And that's why there's some argument amongst maths people. Do we include 0 or not? And all right, so here we are. X is greater than or equal to 0. All right, let's pause there. But when you do your weekly work, I want to remind you, you don't just say, oh yes, when you read this summary table. You've actually got to say, what on earth do they mean? And if you look at 1 over x, x is not equal to 0, you've got to say, oh, of course, when x equals 0, 1 divided by 0 is undefined. So make sure that you do that thinking. Smiley face if you are good at slowing yourself down and reading for meaning. It's a really important skill. All right, so if you are a person who rushes, please slow yourself down, and I believe that if you look at it carefully, you'll save yourself time in the long run. Of course, if you understand it really well already, yep, go on as quick as you can. All right, everyone. Brianna's going to stay behind just to... No, you may not need to. Brianna, I'll offer her. All right. Taylor, you stay behind and we'll have a little talk. The rest of you can say goodbye to each other, but you're welcome to stay behind if you wish. So say goodbye, but stay behind if you want to. See you later, everyone.
Bye, everyone.